Welcome back to Basic Mathematics. In this video, we're going to be talking about multiplying decimal numbers. Without further ado, let me get my head out of the way and let's dive right into it. Since we know that we can think of decimal numbers as mixed numbers or as fractions, if I want to multiply something like 3.28, 3 and 28 hundredths, times 2.7, 2 and 7 tenths, I want to take my inspiration from the process of multiplying mixed numbers. To multiply mixed numbers, we rewrite them as improper fractions. We multiply across the numerator and we multiply across the denominator. 328 times 27. Well, that seems horribly unpleasant, but we can figure it out. 7 times 8 is 56. 7 times 2 is 14, plus 5 is 19. 7 times 3 is 21, plus 1 is 22. Move over one space, 2 times 8 is 16. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6. Add that all together. I get 8,856. But then in the denominator, I have 100 times 10, which is 1,000. Or rewriting this as a mixed number. I know I could reduce this fraction, but it's not helpful to reduce a fraction since I'm talking about decimal numbers at the end anyway. I end up with 856 over 1,000, which is 8 and 856 thousandths, 8.856. The interesting thing that happens here is that when you multiply decimal numbers, you end up with more places after the decimal point than what you started. And since we're multiplying powers of 10, we can predict. When you multiply 2 powers of 10, the number of zeros in the result is the total number of zeros in each of the things you started with. Right? 2 zeros here, 1 more there, 3 zeros at the end, 3 digits after the decimal point. A shortcut that is often taught is count the number of digits after the decimal point in each of the numbers you're multiplying, add them up, and that's how many digits will be in the number after you finish multiplying. So to avoid all of the right things as fractions, we can use that to our advantage. Let's take 4.5 times 0.28. We are going to do the exact same thing we just did, but we're going to kind of ignore the fractions and try to pretend we don't have to do that. When we rewrote our decimal numbers as mixed numbers and then improper fractions, we got the digits in the same order that we had before. They were just missing decimal points. So when we want to multiply like this, we're going to write down the digits in the same order, but completely ignore the decimal points. And we're going to calculate 45 times 28. 8 times 5 is 40. 8 times 4 is 32, plus 4 is 36. Move over a space, 2 times 5 is 10. 2 times 4 is 8, plus 1 is 9. Add that up. I get 1,260. But that's not the end of the story. there is 1 digit after the decimal point here and 2 more there. All told, that's 3. So I need there to be 3 digits after the decimal point in my answer. 1.260. In scientific work or in anything precision measurement, that 0 at the end may or may not be important. For our purposes this semester, we're not going to worry about it, but I do want to warn you, if you're going on to take technical coursework in mathematics or in any applied mathematical sciences, that might become relevant later on. For right now, we're just going to say, well, it ends in a 0. We can drop zeros at the end of a decimal number and give our answer as 1.26 instead. I'm not going to make a big deal about it either way, because like I said, depending on context, the zeros at the end may or may not be important. But it's something that is worth knowing offhand and thinking about moving onward. And the MyMathLab homeworks will care about trailing zeros at the end. They don't tend to like them. So another thing to be careful and pay attention to.